Okay, in this video we're going to talk about how if we think about a solution as an equilibrium where the saturation point represents the equilibrium condition, then we can use that as a way to predict if a precipitate will form or if a crystal will start to form within the liquid, whether a solid will come out of the solution. Basically what we're going to use here is our equilibrium quotient Q, which is the same as our equilibrium constant, but recall this is at current conditions. And so what we're going to see is if Q is greater than K, that means we have more products than reactants that we're supposed to have, because that's what K is. So we have more. And recall that when we write equilibriums for dissolving salts, we always write them this way. So that means we have too many products. So that means this equilibrium will shift this way, and that means a precipitate will form. If we have Q equal to K, that means that we are at our saturation point. This means no more of the salt will dissolve and no crystal will form, but whatever crystal exists will continue to exist. So no more dissolving or solid formation. This solution is stable as it is. And finally, Q is less than K. This would mean that we have more reactants than we would expect to have at equilibrium. Or the proper way to think about this one, because the reactant concentration is not variable, is less products. So we have less of these, which means in this case, the reaction would try to go this way, and we are in the unsaturated situation. Which means if there is a solid, more solid can dissolve. It also means that there will be no precipitate formed. So what we have to do here is we have to use our given information to find Q. Once we have Q, we can compare it to K to determine if it's bigger, equal, or small. If it's bigger, we get the precipitate. If it's equal, it stays the same. And if it's small, we get more dissolving or no precipitate. So here's just a problem for us to work with. We have lead chloride dissolving into lead and chlorine. At the current, keep in mind that solubility is very dependent on temperature. So these K values are going to depend on the temperature of the solution. So here we have, we're going to give ourselves a K of 1.2 times 10 to the negative 5. We're not really going to use that number except to compare it to the other numbers. And we have that reaction in those initial conditions. So for calculating our Q, we have the concentration of lead, 2 plus, to the power 1, because it is a coefficient of 1, and the concentration of chlorine minus, to the power 2, because it has power 2. And we can substitute our current, and we don't put anything in for the reactants, we just put in 1, because lead chloride is a solid. So 1.5 times 10 to the negative 3 times 0.2 squared. (1.5 exponent negative 3 times 0.2 squared). And I get 6 times 10 to the negative 5. So at the current condition, my Q is greater than my K, which means I have more products than I should have, which means this reaction will shift backwards to the reactants, which means a precipitate will form. So that's how we can use the equilibrium quotient, or the current conditions, to predict whether or not a solid will form in a liquid based on whether we are above the saturation point or below the saturation point.